Hello everyone, welcome you all to the TechGig webinar. Thank you for joining the session today. The topic of today's talk is using deep learning for cybersecurity, part 1. It will be a 1-hour session with around 40 to 45 minutes for the presentation and the remaining time for the Q&A. So if you have any questions, please send them to us using the questions tab on the GoToWebinar control panel. I am Nishant, the moderator of this session, and it gives me great pleasure to introduce you to our guest speaker, Dr. Satnam Singh, PhD, Chief Data Scientist, Acalvio Technologies. Dr. Satnam Singh is leading security data science development at Acalvio Technologies. He has more than a decade of work experience in successfully building data products from concept to production in multiple domains. In 2015, he was named as one of the top 10 data scientists in India by Analytics India magazine. He is holding a PhD degree in ECE from the University of Connecticut and Masters in ECE from the University of Wyoming. Satnam is a senior IEEE member and a regular speaker at various big data and data science conferences. So without any further delay, let me introduce you all to our guest speaker. Over to you, Dr. Satnam.
Hello audience, welcome everybody to the webinar, and I'm glad you could take out the time and carve out 1 hour of your valuable time to learn something. So I'm here to talk about deep learning in cybersecurity, and this is sort of our effort to disseminate more knowledge and bring more people to cybersecurity. And so this will be a series of webinars. So this is the first one today. So let's get started. Okay. So I will start with a problem. What's the cybersecurity problem? And what are the typical basic controls we do in a security? And talk more about from a security data science and machine learning point of view. Then get into the deep learning. I'm not going to give you too much of detail of deep learning, but I will talk about basics of deep learning. Then we will together build a deep learning network. We will use a Keras, IPython, and TensorFlow, and we will build a deep learning neural network. And this will use it for Tor, non-Tor traffic classification. So let's get started. So as we all know that the traditional security perimeter, what we used to have, it's all broken. I mean, it's more than a decade now. If you talk about an organization is actually has lots of offices. It has a regional office, headquarter office, data center, multiple cities. So, somehow with the network segmentation and with the firewalls, intrusion detection system, intrusion prevention system, we were able to manage that perimeter and able to have that network control. But that control is broken after we got a mobile, after we got the IoT devices. User is shuffling between various places in various devices. So you can't really control where the user is going to be and which kind of network he will be using, right? If he's traveling to airport, he's going to be using the airport Wi-Fi. If he's going to the coffee shop, he may be using a coffee shop Wi-Fi. And there may be, some vulnerability there, or some, this is all open, right? So some kind of link the employee clicks, and the malware and the various kinds of botnets and everything can get into the perimeter. So you really don't have a control. So in order to have all this security, what we used to have is a different kind of controls and different kind of mechanisms. So if we talk an organization holistically, it has a lots of security problems. Like if you need to address the security, it has to be addressed at various layers. It's like an onion. So it has various layers, and you have to protect at each and every layer. For an example, network security, endpoint security, application security, data security, and so on, right? I have listed here 10 of them. It's just the major list, right? The list to secure is much more than that. And I think the topmost should be the user security, bringing the user awareness as well. So security as such is a tough problem. And if you think about doing the security at various layers, it becomes even way tougher, right? So how we have been looking at as a defense, how we have been doing this defense is doing using the basic security controls. Like if you talk to any incident response, or if you talk to chief security officer, he will say that first you have to have the basic security controls, and this is what it means by basic security control. You need to have the firewalls, the intrusion detection system, intrusion prevention system, basic controls for the perimeter, then something for the malware, something at the endpoints, then some way to do a whitelisting, some way to do the vulnerability management, and some way to do a user access control. Not everybody should have a control what he's not supposed to have, right? So the access control should be well and crisp defined and controlled. Then having the configurations also secured. So there are various aspects of the basic controls, and that has to be done first. Okay, those are the basic foundation of security that has to be done. But beyond that, we need to do something more. And if you look at the evolution of the security data science as such, there are other control mechanisms as well. I'm not going to talk about them, but I'm just going to be limiting my discussions only from a data science perspective. So if you look at the security data science, it started with the rule-based anomaly detection methods. It was primarily in IDS and IPS, and also in the host-based, that used to be host-based and the network-based intrusion detection systems. But then it evolved with the data mining, with having more pattern-based anomaly detection. Then with the evolution of big data and machine learning, it became more of a much more automated. And the anomaly detection started being also modified into a supervised machine learning problem as well. So now when we talk 2018 and beyond, uh, everybody talking about the deep learning and all that, right? So if we want to understand where we can apply deep learning, we need to have little more understanding of what are the different data sources in the security domain. And here are some of the data sources I have listed. So first thing is, like, all the data sources in security, it starts with in the form of logs. They are either they will be some kind of a key value pairs, and or you may need to write your own regex to extract those fields. And these logs are coming from network, endpoint, and authentication, and so on. I have listed them, many of them here. The one thing I want to stress here is the network logs, like bro logs. Like, if you start logging each and every communication and network communication between the host, it pretty soon runs into terabytes. So the data volume becomes huge. And if you start doing some analysis on it, from a security data science point of view, one of the challenge would be that if you are trying to raise anomalies, you have to control how many to raise. And I will talk about that as well. Now the endpoint logs. Endpoint logs are, each endpoint will be, if you start logging those as well, that will be again a huge. file system changes, applications, and process and OS logs. Authentication logs, Windows security logs are one of the key events and key logs, and it is heavily being used for the security. But another thing I would like to highlight that these logs certainly capture the signal of what adversary is doing and where the threats are. But signal is too less and the noise is too much. So this problem is highly skewed. It is a low SNR problem, low signal to noise ratio problem. So whichever algorithm we come up and whichever frameworks we come up, it has to handle all that. And on the top of that, there is no such label available that, okay, this thing is a malicious topic, malicious traffic, and this is a malicious file system change, or this is a malicious process. You can't label all that. It is not, those labels are not really available. You have to start somewhere and say that, okay, this is what my baseline looks like, and then start saying this is what the anomalies are. And then you say that, okay, those anomalies, some of them actually are malicious, and then you start labeling it. So then once we talk about the labels, now we can talk about deep learning, right? Because we have the labels available. And from my discussions with security analysts and also a couple of senior folks in security, and looking at the various literature and the technology providers, this is what I have captured here. I have seen the deep learning use cases primarily into these buckets. And some of them, like a network intrusion detection, I have seen that it has really come into a real world as well. Some of the technology providers have started using deep learning. Phishing attack and the malicious URL detection, now that is also being, these use cases being also leveraging deep learning. Endpoint security as well. Some of the malware detection is one of the predominant field where deep learning is heavily used. And it is primarily because malware samples and what kind of malware samples, what family they belong to, that is well available, and that industry has come from multiple years of evolution. So those labels are available. UBA is also one of the direction where it is leading more towards the deep learning. So, these are the various use cases. Now, let me dive a little more into a deep learning. What is deep learning? If we look at much more like more of a broader view of neural networks and the deep learning as such, it has changed quite a bit in last few years. It started with the feed-forward neural network, which have been there from decades, but it has came with a more compute power. Now we are able to get a lot more higher number of hidden layers. So it has transformed into a deep uh, feed-forward neural networks, which is more on the right I'm showing here. And then the last few years, the recurrent neural networks and LSTM, they have actually powered a lot of use cases where uh, you want to analyze the time series analysis data. You want to analyze the data over a period and over the sequence, and sequence to sequence analysis you want to do. And another family of deep learning networks are the autoencoder and so on. Those are like in the unsupervised category, unsupervised learning. Because if you don't want to specify the features and you want to learn the features, and then you apply the autoencoders. Then we get into these convolutional neural networks. They have been very popular in images when you're analyzing the image and you want to do image classifications. So I would suggest that take a look at this particular asimovinstitute.org, and they have a fantastic blog and the various neural network. And another thing they have done is they have also linked with the originating papers. So if you want to get deeper into each of these networks, you can read the corresponding paper as well. So what I will do is I will start from the basics, and then then we will together build a one deep neural network. So if we start with a single neuron, yeah, as we all know that it all got motivated from the brain cells and this research of decades and this neural network being there. But I just want to sort of remind them in terms of our notations and when we will discuss in further. So the notation wise here, we are representing the input values with the axis and the bias being shown as x0 and x1, x2, xm. There are m input values here. And the weights, they are weighted with some w0 to wn. Now, the first thing it comes is you do a summation. You take a summation of the multiplication of the input with the weights. And then you apply some kind of an activation function. And then you get an output. What we will see that if we get these weights, then this kind of architecture can learn any function. And that's the beauty of neural networks. That it can learn any nonlinear function as well and a linear as well, anything. And the challenge is how do you come up with the weights? So here are a couple of very short examples. So let's say you want to model an AND node. And if you want to model an AND node, you give the two inputs and you give the weights with a bias as well here. And you get the summation value as minus 1.5 plus x1 plus x2. And you apply this activation function here, the step function. What you will notice that you are getting the AND node. So how you are able to get, because if you specified the weights, what it should really, in this case, if you apply the weights and you apply the activation function, then you get the function what you wanted to learn, that AND node, you got that. Now let's take another example, OR node. In this case, you just change the weight for the bias node. Then, and you keep the same activation function, you get the OR node. So what this does is sort of gives you very intuition that if you want to represent a function, if you want to approximate a function with a neural network, it is possible by changing the weights and by learning. Next we'll talk, right? How do we learn these weights, right? And then we will get into the practical demonstration of that. So the question comes that in a neural network, how do we learn these weights and how do we get these neural network computations done? So the way it starts is first you specify a network. What kind of network do you want? And I'm starting with just a 3-layer neural network here: input layer, hidden layer, and output layer here. And it can be as complex as this. In the demo, I will show you that we are using some 10 layers, right? You can use 100 layers, whatever layers. It all depends. How much compute you have to do and what's the complexity of your data set. So in this particular case, we start with the input layer, and we multiply the inputs with the weights. You get here the z's, and you get I'm representing the summation, the multiplication of the weights and the inputs, and then we activate that. The same philosophy what I showed here for a single neuron, that philosophy remains. You multiply the input to the weight, you get the summation, you activate, and then you move on to the next layer. Then in the forward propagation as well, you apply the activation, and that activation is being applied with the sigmoid function here. And this is being going on from input to the hidden layer and then hidden layer to the output layer. So the same thing here, what it shows that the input to the hidden layer, it is showing more on a matrix and a vector representation, so that this entire computation becomes more of a matrix multiplication, and so it will be way faster. And then you can also do the parallelization as well, and that's where the compute power becomes very handy as well. And so once you got your multiplication done with the weights and the input, then you apply the activation, and you get the output for that. Then you again apply from input to the output layer, and you get the multiplication done with the weights, and then again you apply the activation. So the same thing you continue for as many layers as you want, and this is called the forward propagation, because you are carrying forward the weight multiplication and the activation in the forward direction. The next thing what we do is, if we want to learn these weights, right, we have to get something feedback. We have to do some back propagation. What it means is these weights have to be learned, right? So this there, you remember, right? We had these weights. What we learned these weights here, we specify just like minus 0.511. How do you know that, right? How do you know at the first point that what these values should be? So the way you do is you start with some random values, and then you see, am I getting the output what I want? And if you're not getting it, then you compute the error, and then you tweak these weights. So if you specify some other things here, some other weights, and you get the other output, and you know that your desired values are these, and whatever values you are getting here, as in you compute the error, and then you again go back and tweak these weights. So how do you do that? So that is being done as a backpropagation algorithm, and the way it happens is you compute what is your true value and what is the output here, what the output you're getting from the neural network. You compute the delta between that error, and then you propagate that error in the backward. And the way to do that is you have to first start with some kind of a loss function. In this particular case, it's starting with a cross entropy loss function, which is very popular for the classification. And the idea is basically you are trying to know the distributions between the difference of distribution between what's the true and the prediction in terms of cross entropy. So I think I'm not going to get into the details of the derivations here, but what I want to say is you need to tweak these weights, and that has to be done using some optimization. And there are lots of variations of optimization techniques that can be applied to tweak these weights. And I would refer to this particular book here, Python machine learning book, and it has a very nice way of explaining with the code and along with the equations. So I would recommend you to look at it. So let's get into a much more practical mode, and we will experiment with a data set. So for a practical demo and a practical making a neural network, I picked up this particular case study, Tor network, and the reason I picked up is basically the data was available, and just to give a little introduction about the Tor network. Tor network is a way to send the data in an anonymous way from one node to another node over the internet, and it was primarily being built to secure the privacy and to keep the privacy, and so because everything is being monitored on the internet, but if you send it through the Tor network, then it will be anonymized. But unfortunately, it is being also used for the malicious intent as well. And here is some data from Cloudflare and Distal Network, which shows that a large percentage of the malicious traffic actually flows over the Tor network. So, and they have been adversely been using this Tor network for various bad intents, extortion, data exploitation, and so on. So it is an interesting example from a security point of view. So how do we get the data set? The data set, we got it from the Canadian Institute for Cybersecurity. You have to write an email to them and they will send the data. And, we got the data. How the data set looks like, they have various data sets in terms of the volume. And so one of the data set we picked up here, and I will show you that for the case study here. They did a bunch of users did some activities to get the data, for example, browsing, email, chat, and so on. And they used our day-to-day tools like Chrome, Firefox for the browsing traffic. And they also generated, they generated the normal traffic and the Tor traffic as well, using the Tor network. So what we will demonstrate that how do we classify and detect Tor traffic from non-Tor traffic. So let's start the demo part and let's build a deep neural network. So what we'll do is, by the way, this is a book I was referring to, and you can also find it online. So let's see the data set first, how the data set looks like. Okay, all right. So the data set, I'm just showing it here in a CSV file, but there is a version of the data which is actually a lot more, and you can't even see it in a CSV. But I just picked up here so that I can give some more intuitive feeling of the data. What you see here, the source IP, source port, destination IP, destination port. The data is being flowing from one source to destination, so it shows the IP addresses, ports, the protocol, the flow duration, and the various data they have collected using so-called their own version of their own version of Wireshark and their own variation of flow meter. So all the details are there at Canadian Institute for Cybersecurity. You can actually take a look at, they have described how they collected the data. I'm just showing you here one glimpse of the data, how it looks like. There are various attributes here, roughly 28, 29 attributes. So what we'll do is let's start analyzing this. And let's get to our IPython notebook. What we can do is, the first thing is we load the data. We load here in our data frame. We get a pandas data frame. And if we take a look at the data here, and I'm just describing the data here with a data frame dot describe. What you notice here is the values are varying a lot, right? For example, flow IIT is flow IIT min, max, standard deviation. I mean, they have, they are varying into some exponential values here. And some of the other values may be very less as well. So we can apply lots of pre-processing techniques here, and I'm just showing one pre-processing technique here, which is very simple, is normalizing the data. So we normalize the data. Another thing is, as I showed you, that we have the initial 3-4 columns are the source port, destination IP, and destination port, and so on, right? So what my understanding says that, right, like if you take this model and you put it somewhere else, you're not going to be taking the IP addresses in the data, because if you train the classifier with that, those IP addresses will be changing from network to network. So it doesn't make sense to take the IP addresses at least. Now for the ports also, these ports could be also varying. So you can keep it, but just for experimentation here, I said, I'm not going to keep these as well. So I'm sort of like using a domain knowledge to do a one first stage of feature extraction, sorry, feature selection. But you could leverage, any other techniques as well to do a feature selection. And, in my part two, I will show that, we can actually use an autoencoder to do a feature selection, and then we build a neural network. So here I'm taking it from the protocol onwards, right? The protocol, flow duration, and so on. And these are the various attributes I have selected for the for doing the further classification here. Now we got the normalized X data, and we apply the labels as well. We are applying the non-Tor as 0, and then we are applying the Tor as non-Tor as 1 and the Tor as 0. So let's get started here. So what we do here is, first we apply any of the base classifier, and since I'm taking the less data here, so we can apply any of the neural network, any of the machine learning classifier as well. I picked up logistic regression here. We can also pick up any other one as well. So we apply logistic regression, and what we get here is we get a 93% accuracy, and the numbers are shown here. The precision recall numbers are also shown here. So next thing comes into picture is that, okay, let's build a neural network for that, a deep neural network for that. So what we need for that is we need some more libraries. So we need TensorFlow, Keras. So I've imported all those libraries here. And then we specify how many layers do we want. In this case, we are specifying 10 hidden layers. And we need to specify the input dimension. So in this particular case, we have the feature underscore dimension, which is, I believe here, the 24 as the feature underscore dimension value. So 24 neurons will be there in the input layer. And then the hidden layers will have 128 neurons. And we are specifying 10 layers. And it's going to be the deep feed-forward neural network. And we specify ReLU activation here. And the output layer is going to be again a dense layer, and having an activation, a sigmoid activation, because it has a binary classification, and a sigmoid works pretty good here for a binary classification. And we specify the loss function as binary cross entropy. And let's run this model. So what we get here is, first of all, we get the model summary here. So by the way, if you want to take a look at this in TensorBoard, then you can also specify the callback as a TensorBoard. Then it will be looking at in the TensorBoard. And here you can see that it has the various dense layers and the output. And you can also look at when you do an evaluation on this, and with the model what we learned, we can also take a look at the accuracies and the loss function in a graph. And I would recommend looking at the TensorBoard for that, because it will give you how the data has been, how the learning is going through for the loss function and the accuracies and so on. So, there's a lot to do, a lot to talk about, but I'm sort of giving the pointers here. How do we proceed with that? how do you build a network. So once you build a network, then you come here and you got the evaluation done already, and that's where you see the loss function and the accuracies there. So what you get here is you get a 94.73, higher accuracy than the base classifier what we specify. It shows that the class 0 has a less accuracy. There is a lot more work has to be done. Some more feature engineering has to be done as well. And what I've done is very simple, right? I just picked up, just specify the features, pretty much all the features. So let's do a little bit of changes here and then, see what happens to the accuracies. So, okay. So what we'll do is let's change some values here. What we can do here is let's specify maybe lesser number of features, okay, and then see what happens to the accuracies, okay. So let's build that again. I'm just going to run all. I know I did a change in between, but I'm just going to run all, and then we can take a look at that. So let's see what the logistic regression is going to get, and we'll see that. Okay, so the accuracies drops because I'm taking the less number of features, and we are getting the. Let's look at the neural network here. The neural network accuracies have also dropped. Let's look at some of the numbers here. Also, the numbers are changing as well. So let's see the numbers. Now we can see the numbers are changing as well. Okay, so we got the numbers here. Well, class 1 accuracy has slightly increased, but the class 0 accuracy has slightly dropped. So, I mean, we can experiment with the features, and I just change the number of features, but a lot more can be done. We can apply some more feature selection techniques, and we can also use an autoencoder to really construct the features what it's supposed to be, and in a sense like more in an unsupervised manner, and then we can feed it to the neural network. So a lot more things are possible. What I will do is I will leave I will share this IPython notebook somewhere maybe over LinkedIn or in a Twitter, and I will at a GitHub actually, and share the link somewhere with from my Twitter account or LinkedIn account, so that you can experiment with it. Only thing is, I'm not going to share the data. You have to get the data from Canadian Institute of Cybersecurity, because the data belongs to them. So you have to write to them and then get it from there. Okay. All right. So what we'll do is we saw a demo as well. We'll give a summary of it. So to summarize, what we talked about, that cybersecurity is a complex problem, and if we have to, first of all, we have to have basic security controls, but on top of that, we need to have sort of like leverage combination of different technologies, and security data science offers another layer of security. It gives you a way to find the anomalies, and unfortunately those anomalies are a lot. even if they are 0.001% or 0.01%, the data is huge, so the number of anomalies are huge, and we really don't have that many security analysts to investigate them. But there are use cases. If we start making more and more sub problems into a supervised machine learning problem or into a deep learning problem, then we can actually solve the problem much more efficiently. Okay, so this now the question comes that where to go from here. What do I do as a participant? If I am joining this webinar. So my suggestion over there is get the Tor traffic data, experiment with it. I'm going to share the IPython notebook. Get the basics done. Get this one running on your computer. Change and tweak some of the parameters. Change the features, and share your results. And I promise I will share. I will acknowledge you on social networks, and I will acknowledge you in our next webinar. So continue your learning. And if you are more ambitious, then you can also pick up some more papers and talks. And here is a GitHub link. And this link has a lot more links to various papers and talks. And here is a place where to find me, either on Twitter and LinkedIn. Get connected, and I keep sharing my knowledge with everyone. So I think with this, we can start with the questions. Hello, can you guys hear me? Okay, so let's start with the questions. So the question, so first question is from Chetan, and he's asking, can you please explain more about CNN? So Chetan, you have to wait for the next webinar. I'm going to go into the details of CNN in my next webinar. How can we classify? So next question is from KP Patel. Okay, all right. KP Patel is asking, how can we classify different malwares through deep learning? So KP, what typically happens that for each malware family, you can construct the various features. It is sort of like representing a malware as an image, sort of equivalent to that. And then you construct the features, and you already know the class labels, and then you feed it to a neural network. So convolutional neural networks have been very successful in malware classification. And I would recommend, take a look at some black hat talks, and they describe very well that how to do a malware detection and the malware classification. Okay, can you say about ethical hacking? This is slightly beyond the topic of this talk, so I'm gonna skip this question. Okay, so there is a question from Murli that he's saying that I am a Java developer and I want to switch to cybersecurity. How do we do it? Well, there is always a way to learn, and if you are anybody who wants eager to learn, and there are lots of places to start the learning. I think I would say that start from the basic places like Coursera, and from some of the MOOCs, Coursera, Udacity, pick up some of the courses from there on cybersecurity and machine learning and data science, and then you pick it up on a deep learning as well. Next question, as we are trying to, okay, as we are trying to classify the results. Okay, just a minute. I think I'm not getting this question properly. How shall we know these weights are perfect for output? Yeah, that's where I was saying that we need to learn these weights. Uh, so just Nishant, can you hear me well?
Yes.
Yeah, okay. I just wanted to make sure. Okay. So the question is, how shall we know these weights are perfect for output? So Nasir, this is basically, we start with the any random weights, and then we have to learn these weights using the optimization technique. And I showed you some example there where you learn these weights, and this is you have to experiment with a very simple example on your own, so then you will get a lot more uh, sort of intuitive feeling of how these weights being learned. Okay. All right. So there is another question here. I really need to learn from beginning. Where can I learn? And I answered all this already, that we have to start from the basics. Uh, the places to start are different MOOCs, and there is a lot of information on free courses are available, and YouTube videos are available. The GitHub has a lot of code. So I think these are the places to start and build up slowly. All right, how does backpropagation work in a deep learning? I gave a very intuitive feeling of that in my talk, and I also referred a book for the details. Okay, there is another question here, that how the vulnerability happens. A vulnerability could be uh, in anything, right? Could be in any software or any hardware as well. So vulnerability is like, you can think of like there is, you write some logic, and you don't think from that how attacker can actually exploit the input to that function or that API or that piece of code to really behave in a different way, the way you want. So it is something like, let's say a very simple example I would say is a cross scripting attack over the web, right? So if your website is directly connected with a database, and you're writing a SQL query, and in that SQL query is exposed over the internet, then you can guess, what input to give, and then you can just form the input the way you want, and then that basically illustrates that there is a vulnerability there. So this is a very simple example, but in the vulnerabilities are, you take a look at like Adobe PDF reader, right? Is being updated almost like 3 to 4 times every month, right? Because there are different types of vulnerability in different products and different applications. So that itself is a big industry altogether. Another question, how do we get the data sets? I showed that you have to contact, for this particular data set, you have to contact the Canadian Institute for Cybersecurity. The question is, what is the difference between feature extraction and a feature selection? Well, in this particular case, feature selection is much more appropriate, because my data set was much more. It was having a numeric fields, and uh, if you are having the numeric fields and much more systematic data, so in this particular case, you really don't need to extract the feature. But if it is an image or a sound, then you need to extract those features. That's where you don't have a very structured data. That data is unstructured, so you need to extract. And the same is with the text data as well, right? You need to extract the features. But in the case of numeric data, those features are well defined already, you may be either doing some kind of a selection, or you may be doing some combination of them or some transformation of them for doing a feature engineering. Okay, I don't know how to use IPython. Well, you have to use the internet for that. How do we get temporal data set generation tool? As I said, like the data set, we have to get it from the university I listed over there. Okay. Another question is, please confirm how can I use Kali Linux for cybersecurity? That's actually a different question. You have to look at the more of a pen tester talks, and there they will explain that how to use the Kali Linux. Any other tools you recommend? Oh, there are a lot of tools depending on what's your interest. If you want to be a pen tester, then you need to know multiple tools. PowerSploit, Mimikat, PowerShell attacks are very popular, and so you need to get comfortable with them. And Metasploit, these are the various attack tools. You have to start leveraging them. What is ReLU? ReLU is one of the activation function, and there are different kind of activation functions. And ReLU is another popular one, which gives you the nonlinearity. And this nonlinearity helps the neural network to learn better. Can't we use scikit-learn? Well, we can use the scikit-learn. I showed that we used logistic regression, and that was from scikit-learn. But what I was referring that if the data set is huge, then we need to have a deep learning, and there the scikit-learn, you get into much more of a memory problems and all that. So you need to scale it up and use different tools for that. What are the pros and cons for deep learning? Well, that's a good question. The pros and cons are like, obviously you need to have a good amount of data and good amount of labeled data for deep learning to happen. And I would say that slight disadvantage is that it's sort of a black box, and it's not like a decision tree where you can actually see what features you are getting. But in the case of terabytes of data and you are applying deep learning to that, you really don't have a way to understand what is going on. But deep learning is very powerful if you apply to huge data sets. In the case of images and in the case of NLP, for the text data and for the machine language translation, they have been very successful. And Google, Amazon, and Microsoft, they have built a lot of use cases on the top of deep learning. Okay, if we add more layers, then will it affect the accuracy? Oh, yes, it will affect the accuracy. And I'm going to share the IPython notebook. You experiment on your own and you can try it. And the idea is that like the more layers would actually help to learn more features, sorry, to learn more from the data. And that's where it will impact the accuracies. But there is no thumb rule as such, but it all depends on, it's highly dependent on the data set and also the other attributes as well. Will you also teach us how to use TensorBoard? So actually, I'm not gonna be I won't be discussing that. I would recommend that there are TensorBoard tutorials available by Google and over the YouTube and also on their website. So you basically learn from there. Gonna pick up another question here. Can we use NoSQL DB to log and prepare data? So that's another interesting question. And I haven't talked about that. That how do we do the log processing as such? So you remember, like in my demo, I started with a CSV, and there is a ton of work which uh, Canadian Institute for Cybersecurity, they already did that. So they had the logs and they processed it, and then they converted it into a CSV file. So my recommendation is to use any of the log processing techniques, processing tools, a combination of Elasticsearch and Logstash will give you uh, the logs to structured data. Another one, if you are experimenting on your just for your own learning, then you can also use Splunk. You can process the logs, and then get the structured data, and then you apply the deep learning and the machine learning on the structured data. Okay, this is another interesting question that do I need a PhD for an ML engineer? You certainly don't need a PhD. You can just pick up on your own, and in my team as well, I have lots of non-PhD guys as well. So I would say that you don't need a PhD. You need more of curiosity to learn new things and determination to keep on learning and keep trying. How is hidden layer decided? So it is sort of an art. I mean, it is one of the parameter, but there are uh, tools now available like AutoML. These AutoML tool, you can use it, and that tool will be changing on its own, and then it will be doing some sort of a grid search and doing a parameter search that how many hidden layers should be there. So it is sort of like one of the parameter. You can actually tweak it based on your experience, but also you can learn that using various automation as well. AutoML tool is one of them. Any good book on ML? I just referred in my talk. Uh, how to prevent server machine from a ransomware? Well, nothing can be prevented from ransomware attack as such. I mean, you definitely need to have the basic security controls, but I would say that having the basic security controls, and then also along with that, making sure that you have some kind of a cloud backup as well, and then doing all those, also doing a log management will definitely help you to really know if something happens, then where things went wrong. Okay. So how about a weighted matrix decided? I didn't get the question here. I think it was more to, the question is more to how do we learn the weights and how do we get the weights. So that I showed that we actually learn these weights using the backpropagation algorithm, and that algorithm leverages various concepts. So I would suggest that you get the details from the internet. Okay, differentiating Tor data with not Tor data. Yeah, that's what we demonstrated that. We already had the label data, so the data already had the labels. And let me show you that data again, because this is very important question, and I think I missed out also when I was showing it. So here is a field called label, and this label field will say that whether this particular row, this particular feature is actually a non-Tor or a Tor. So this data we are feeding it to the neural network, and when you do the any unknown data, when you send it, then it will say whether it's a Tor or non-Tor. So I think we are reaching out on the time limit here, and I would say that take a note of my Twitter handle and the LinkedIn information here, and I will be sharing a lot more information about what to learn, where to learn, and also uh, this particular IPython notebook as well. So you can learn it from there, pick it from there, and experiment on your own and join the next webinar. Over to you, Nishant.
Thank you so much, Dr. Satnam, for this really empowering and motivating session today. I would also like to thank all our participants for making this webinar a great success. This session has been recorded and the recording will soon be available on techgig.com. Thank you everyone for joining us.
Thank you, audience, and thank you, Nishant.